In one of the hottest, driest places on Earth, rocks weighing up to 700 pounds move across a dry lake bed entirely on their own, leaving long, perfectly traced trails behind them. Nobody has ever seen one move in person. For over 70 years, scientists studied the tracks, built theories, and set up experiments, and the rocks kept moving only when nobody was watching. Then, in December 2013, for the first time in recorded history, that finally changed. This is Racetrack Playa, a dry lake bed inside Death Valley National Park, California, one of the most extreme environments on Earth, and home to one of the strangest, longest-running natural mysteries. In modern science, scattered across its flat, cracked surface are hundreds of rocks, some weighing as much as 700 pounds, each one trailing a long, often perfectly straight track carved into the dried mud behind it, as if the rock had simply decided to go for a walk. Researchers have documented and studied these tracks since the early 1900s. For most of that time, nobody could explain them, and more importantly, nobody had ever actually witnessed one of these rocks in motion. The stones seemed to move only when no one was there to see it happen, a genuinely rare case in science where the evidence of an event, the tracks themselves, was everywhere, while the event that caused it remained completely unobserved for the better part of a century. Let's start with what makes Racetrack Playa such a strange stage for this mystery in the first place, because the location itself matters enormously to how this eventually got solved. Death Valley is famous for being one of the hottest, driest places on the planet, which makes it an unlikely setting for a mystery that, as it turns out, depends entirely on ice. The valley itself sits within a tectonic basin formed by the same regional stretching and faulting responsible for much of the broader basin and range geological province across the American West, a landscape shaped by the Earth's crust slowly pulling apart over millions of years. Racetrack Playa itself is a nearly flat, dry lakebed, cracked into a distinctive mosaic pattern by repeated cycles of wetting and drying over thousands of years, sitting at an elevation high enough within the surrounding mountains that winter temperatures can drop well below freezing overnight, even though the valley floor itself is famous for recording some of the highest air temperatures ever measured on Earth during summer months. Scattered across this surface, mostly having tumbled down from a dolomite and syenite rock formation at the playa's southern end, are the stones responsible for the mystery, ranging from just a few hundred grams up to hundreds of kilograms. Their origin point is well understood and entirely unremarkable, ordinary rockfall from the surrounding cliffs. What happens to them once they land on the playa floor is where the actual mystery begins. Behind many of these rocks stretch tracks, sometimes just a few feet long, sometimes hundreds of feet, carved directly into the soft clay surface of the playa. Some tracks run in long, mostly straight lines. Others curve, zigzag, or make sudden sharp turns, and in some documented cases, multiple nearby rocks show tracks that shift direction at almost exactly the same point, suggesting whatever force moves them affects multiple rocks simultaneously in a coordinated way, rather than each rock wandering independently. For decades, researchers proposed a range of explanations, some more credible than others. Strong desert winds, some reportedly reaching up to 90 miles per hour during seasonal storms, were an early favorite, on the theory that wind alone might be enough to push rocks of this size across a sufficiently slick, wet clay surface. Other researchers proposed that thin sheets of ice might somehow encase the rocks, effectively increasing their surface area enough for wind to catch and push them along, or that ice might lift the rocks slightly, reducing friction with the ground below enough for even modest winds to move them. More fringe explanations circulated too, including theories invoking magnetic fields and, inevitably, extraterrestrial involvement, though neither of these ever gained any real scientific traction. Each of the more serious theories struggled against the same basic problem. None of them could be confirmed without directly observing the rocks in motion, and nobody had managed that. Researchers studying the tracks could measure their length, width, and depth with precision, could analyze the mineral composition and shape of individual rocks in detail, but none of that physical evidence gathered after the fact could conclusively distinguish between the competing theories about what force had actually done the moving. An early, direct test of the wind and ice theory conducted in 1976 actually seemed to rule it out. Researchers found that the specific mechanism proposed at the time didn't hold up under testing, and for years afterward, the mystery sat in a kind of scientific limbo, multiple partial theories, none of them fully confirmed, and no one who had ever actually watched the process happen firsthand to settle the debate directly. The core difficulty was simple, and in a strange way, almost comical for professional scientists to admit. The rocks might sit completely still for a decade or more before moving again, making sustained observation an enormously patient, often frustrating undertaking. But one of the researchers who eventually helped solve the mystery, engineer Ralph Lorenz, reportedly described the entire research effort at one point as, in his own words, the most boring experiment ever, a joke that turned out to be more accurate than he could have known, right up until the moment it stopped being boring at all. In 2011, paleobiologist Richard Norris of the Scripps Institution of Oceanography, working alongside his cousin, engineer James Norris, and planetary scientist Ralph Lorenz of the Johns Hopkins University Applied Physics Laboratory, launched a dedicated long-term monitoring project specifically designed to finally catch the phenomenon in the act. Their approach combined patience with genuinely rigorous instrumentation. The team installed a high-resolution weather station on the playa itself, capable of measuring wind gusts down to 1-second intervals, alongside 15 individual rocks specifically fitted, with custom-built GPS units capable of tracking their exact position, motion, and timing with high precision. Given how infrequently the rocks were known to move, the team genuinely expected to wait years, potentially 5 to 10, before capturing a single meaningful movement event. What actually happened caught them by surprise almost immediately. In December 2013, just 2 years into the project, conditions on the playa aligned in exactly the specific combination the team needed, and the rocks began to move while the team was physically there to witness it. The first confirmed direct observation of this phenomenon in the entire documented history of the mystery. What they witnessed, and what their instruments recorded in precise detail, finally revealed the actual mechanism behind a century of speculation. And it turned out to require a genuinely rare, specific alignment of conditions, which explains exactly why it had gone unobserved for so long. First, the player needs to fill with a shallow layer of water, deep enough to eventually support the formation of floating ice, but shallow enough that the rocks themselves remain at least partially exposed rather than fully submerged. This alone is uncommon in one of the driest environments on the continent, requiring specific rainfall or snowmelt conditions to pool correctly across the flat playa surface. Second, cold winter nights need to bring temperatures low enough to freeze this shallow pooled water into thin sheets of what researchers called window pane ice. Fragile, glass-like ice, thin enough to break apart easily, but structurally solid enough to hold together as connected floating panels rather than simply crumbling. Then, as the sun rises the following morning, that ice begins to warm and fracture, breaking into large floating panels that drift slowly across the shallow, pooled water, driven by remarkably gentle winds, nothing close to the dramatic 90-mile-per-hour storms earlier theories had proposed. The team's instruments recorded rocks moving under wind speeds of only about 3 to 5 meters per second, roughly 10 miles per hour, a genuinely gentle breeze by any normal standard. The floating ice panels, pushed gently across the water's surface by this light wind, physically shove against the partially submerged rocks in their path, nudging them forward across the soft, saturated clay underneath, which records the rock's path as a visible track the moment the water eventually evaporates and the mud dries and hardens again. This finding directly overturned one of the most persistent earlier assumptions about the mechanism. Several previous theories had proposed that ice needed to be thick enough to actually encase or lift the rocks off the ground entirely, reducing friction enough for wind alone to carry them. The team's direct observations showed the opposite. The ice involved was consistently only a few millimeters thick, far too thin and fragile to lift or fully encase a rock of any real size. The rocks weren't being lifted or floated at all. They were simply being shoved horizontally by the leading edge of a moving ice panel, a considerably simpler mechanism than many of the more elaborate theories that had circulated over the preceding decades. The rocks themselves move remarkably slowly during this process, at speeds of only a few meters per minute, slow enough that a casual observer standing at a distance, without a fixed reference point to compare against, might not consciously register that anything was moving at all. Norris and his colleagues noted afterward that it's entirely plausible some past visitors to Racetrack Playa may have unknowingly watched this exact phenomenon happening in front of them, mistaking the barely perceptible motion for a trick of the eye, or simply not noticing it at all. The research teams published findings appearing in the journal PLOS 1 in August 2014, documented 5 separate movement events over roughly 2.5 months of continuous monitoring, some involving hundreds of individual rocks moving simultaneously across sections of the playa. The mechanism finally matched the physical evidence precisely. Ice sheets, sometimes tens of meters across, capable of pushing multiple rocks along parallel or gently diverging paths at the same time, explaining the long-observed pattern of nearby rocks, showing synchronized direction changes at roughly the same points along their tracks, since they were, quite literally, being pushed by the same moving sheet of ice. So here's where the honest, satisfying resolution of this century-old mystery actually lands. The sailing stones of Death Valley were never being moved by anything mysterious, extraterrestrial, or paranormal. They were being moved by an unusually specific, genuinely rare convergence of ordinary physical conditions: shallow standing water, freezing overnight temperatures, thin fracturing ice, and gentle morning winds, all needing to occur in precisely the right sequence in one of the driest places on the planet for the phenomenon to occur at all. That rarity, not any inherent unexplainability, is what kept the mystery alive for over a century. The wind alone couldn't do it. Ice alone couldn't do it. It took both, combined in a specific and narrow window of conditions, witnessed directly by a small team of remarkably patient researchers who happened to be in exactly the right place after only 2 years of what they genuinely expected to be a much longer wait. There's something worth appreciating in how this particular mystery ended. It wasn't solved through a single dramatic breakthrough or clever new theory. It was solved through old-fashioned scientific persistence, careful instrumentation, and a willingness to keep watching a completely empty, silent desert playa for years, on the reasonable bet that eventually the rocks would move again while someone was finally there to see it. What's left today is a strange, beautiful stretch of cracked desert clay in one of the most inhospitable environments in North America, still covered in decades' worth of overlapping rock trails, most of them carved by movements nobody witnessed, a handful of them now finally precisely explained by science. The rocks are still there. The tracks are still forming, slowly, unpredictably, waiting for the next rare alignment of rain, ice, and wind to send them sliding across the mud once again. So we want to ask you directly, if a mystery this visible, this well documented, and this thoroughly studied could still take more than 70 years to actually witness in person, what other everyday natural phenomena do you think are still waiting for someone patient enough to finally catch them in the act? Leave your thoughts in the comments below. We rate every one of them. If this is the kind of story you want more of, the kind where the real discovery isn't something hidden, but something hiding in plain sight, simply because nobody had waited long enough to see it happen, make sure you're subscribed, because next time we're heading somewhere just as remarkable. Until then, stay curious and keep questioning the version of history you were handed